Hello everyone. Today I'm going to present about the analysis of self-driving car and intelligence system. First of all, I would like to introduce myself. My name is Rajiva and this presentation is based on assignment 3 research project for ICT724 intelligence system. Today I will be analyzing self-driving car as intelligence system. I will be explore their technical foundation, the major challenges they face to real world case study Tesla and way more, the ethical and future consideration surrounding this technology. Let's begin. Let's go to the second slide, the introduction to self-driving car. Self-driving car are one of the most advanced example of intelligence system because they integrate perception, reasoning, and decision-making capabilities to operate autonomously. Their development date back to early experiment in 90s with the significant breakthrough during the DRAPA grand challenges in the 20s. Autonomous vehicles are classified from level 0 to 5, showing increasing level of autonomous. Today, self-driving cars are important because they aim to improve road safety, reduce traffic accident, enhance mobility for the elderly and disabled, and transform urban transformation. This set the foundation of our depth analysis. Let's go to the slide 3, the level of autonomy. The SAE model defines six levels of driving automation. Level 0 means no automation, while level 1 and 2 support the driver with the feature like cruise control and steering assist. Tesla currently operate at level 2, where the system can assist but still require human supervision. Level 3 allows conditional automation, while level 4 enables high automation in controlled environment. Waymo operate at level 4, providing fully automation robot taxi service within the mapped cities. Level 5 is the ultimate goal, full automation, urban automation under all conditions through to company has reached no company has reached it out till now. Let's go to the slide 4 about the hardware challenges. Self-driving car rely heavily on hardware such as camera, lidar, radar, onboard computing units. On major challenges is sensory limitation. Camera struggle with the low light or gear. Lidar can be affected by weather and radar provide limited details. Another issue is sensor fusion. Combining data from multiple sensors required precise calibration which can be drift over time due to the vibration or temperature. The real-time computation is also demanding because autonomous vehicle must process large amount of data within the millisecond. Finally, Edwards, Edwards, Edwards weather condition and the high cost of hardware component further limit scalability and reliability. Let's go to the slide 5 about the software challenges. We already discussed about our hardware challenges. It's about the software challenges now. Software is the core of automation driving, but it presents many challenges. Perception system still struggle with the unusual object and the poor lighting. Predicting human behavior such as presidential suddenly cross the street remain extremely difficult. Path planning must balance safety and efficiency, especially in the dense or unpredictable traffic. Localization can be unreliable when GPS signal disgrade and SD map constantly need updating. Machine learning model required numerous dataset and still struggle with the real scenarios known as edge case. These challenges show the software remain the most difficult barrier to achieve full automation. Now let's talk about the slide 6 case study Tesla Auto pilot full self-driving. Tesla used unique approach, relying on vision-only hardware soft system with the 8 camera and powerful full self-driving computer. Unlike many competitor, Tesla does not have LiDAR installed depending on advanced neural network to interpret camera data. Their software stack include Occupy Network and end-to-end learning model trained on billions of miles of real-world driving data. Tesla also leverage its Dojo supercomputer to accelerate AI training. Its strength include scalability and rapid over-the-ear updates, but limitations remain such as vulnerabilities to poor visibility and concern about the safety, performance, and regularity approves. Similarly, slide 7 also show about the case study Waymo driver. Waymo takes very different strategy. It used the multiple sensor fusion approach to combine lidar, radar, camera, and ultrasonic sensor to create a detailed and redundant perception system. Its software uses lidar based 3D mapping, behavior prediction model, and rule-based decision making combined with machine learning. Waymo has achieved level 4 autonomy and operate robotaxi service in the city like Phoenix and San Francisco. Its strength include the exceptional safety and reliability, but it depends on expensive hardware and SD mapping make it difficult to scale to new location. Now you guys see the comparison between the Tesla and Waymo. You already know the Tesla approach and Waymo approach, but the key difference are sensor camera only versus sensor fusion, strategy scalability versus precision, cost cheap versus high priced hardware, development international consumer development versus local geo French development. All the oversight Tesla seek mass market compatibility, whereas Waymo is concerned with the utmost safety and limited autonomy. It show the two case study about the car show how the things are going on real environment by the level of 0 to 5. What about the software and hardware they use? Another challenges for the autonomous vehicle is ethical issue. Mm, for the first point, safety and accountability. Who is the blame in accident, driver, manufacturer, or software? The absence of well-defined legal framework about the autonomous things, it is still absent. About the data privacy, constant surveillance of environment, possible absence of personal information, and another things is algorithm bias. Artificial intelligence can be used to label underrepresented population, asymmetric accuracy of detection safety risks, and the about the job displacement, about the taxi driver, logistic and delivery can be affected by autonomous, and moral decision making, uh, tailoring problem scenario, hard to program, ethically sound decision. These are the ethical issues. And these slides in slide about the future trend in self-driving car, what will happen in the future. The first about the towards the level 5 autonomy, where we can get better AI, better hardware and software version, advance in AI and computing. The same thing, they're gonna upgrade AI and computing things, and B2X communication, or the car that interact with the infrastructure and other vehicle, self-driving fleets and robotaxi increase the commercial function, mass movement, term logistic automation, and it also impact the urban deployment by the smart city integration, traffic light as the mapping, road sensor are connected. These are the future trend in self-driving car. At last, we are heading to conclusion. To conclude, self-driving car are a powerful example of intelligent system that integrate AI perception and control mechanism to operate autonomously. However, they still face significant hardware and software challenges, especially in perception, prediction, and decision making. The comparison between Tesla and Waymo show that the companies adopt very different strategy, each with the strength and limitation. Ethical concerns such as safety, privacy, job displacement must be addressed before full adoption. With the condition advancement and reasoning development, autonomous vehicle have the potential to transfer global transformation. At last, these are the references where I can do research and put in citation. Thank you guys. Thank you for listening my presentation. That's all.